Hello, I am 9. Today we're going to be talking about section 11.2, and we're still in the chapter 9 and 11 data. This section asks you to decide which function family best describes the scenario. So if you take a look at problem 1, this video goes with problem 1. The table below shows the national average annual price of a gallon of gasoline from 2001 to 2011. So why don't you pause this video for a second and create your scatter plot. Remember that you cannot put the year number 2001 into your calculator. You have to transfer those numbers into year 0, year 1, year 2, year 3, and so on. So go ahead and pause your video and make your scatter plot. I have already created the scatter plot to make this a little bit faster. Okay, if you're done making your scatter plot, let's look at the data. So you're looking at your scatter plot and you see it's an increasing function, but you're not really sure if it's linear. Well, you have another option. This particular scatter plot would be an example of an exponential function family. So it says, sketch the best line of regression for number 2 and describe the family. The line of regression is actually exponential. So I'm going to draw the line of regression on the graph and name the function family. The function family is the exponential. Okay, so state the domain and range. Now, it's asking you about two different things. It's asking you the domain and range of the problem in particular and of the function. The function is the line that you drew on your graph. So let's cut question number 3 into two different sections. Let's do the problem situation on the left and the function on the right. So let's go ahead and name the domain and the range for each part. The domain for the problem situation refers to your x values. So for us, it's going to be year 2001 to 2011. The range refers to your y values. So the range for our problem situation is the gas price. So the minimum, it looks like, is $1.36, and the max is $3.48. So we're going to say that the range is somewhere between there. Now let's look at your function. The function is your equation. The domain is any possible year. Well, you could have a bunch of years in the future. So we're going to say that the domain for your function is all real numbers. That includes any year number. You can look at the past and you can also look at the future year numbers. The range is any price of a gallon of gas. Well, you can have any price of a gallon of gas. You can even have decimals. However, you can't pay less than 0. That wouldn't make sense. Your gas can't be free. So our range for the function would be all real numbers greater than 0, because it has to be more than $0. Okay? Now, the reason I have for number 4 the word function highlighted is because we will be referring to the line you drew on your graph. Does your line, or your function, have an absolute min, max, or neither? Remember, in order to have those, there has to be a change in direction of your graph. So it has to be increasing and then decreasing, or decreasing and then increasing. So this particular graph has none. It has neither a min or a max. And that makes sense. There can't be a minimum gas price and there can't be a max gas price. Number 5 says, does the function represent continuous or discrete data, and why? If you remember, continuous data can be any data value, including decimals. Discrete data is only certain numbers or whole numbers. It cannot be a decimal. So, for example, if you were selling t-shirts, you can't sell half a t-shirt, so that would be an example of discrete data. Because the price of a gallon of gas can be any price, 0.17, 0.15, $2.02, this would be an example of continuous data. Remember, too, this question goes with your dependent variable, so your y variable. create the equation for your function. Okay, so you would input your years into your L1 column on your calculator, just like we've been doing under your statistics menu, and you would input the gallons of gas into your L2 column on your calculator. But instead of choosing number 4 for the linear regression, I believe you would choose number 5 for the exponential regression. So the equation, and you create the equation the same way you created your linear equation. So you would substitute your number in for A and your number in for B. The equation should have an exponent because it's exponential. So the equation that I created was y equals 1.34, that was your A value, times 1.09 to the power of x. X represents the year number and y represents the cost of the gas. So under question 7, we're going to be using the function equation that we created to answer each question. For part A, and I showed all my work on here already, so this would make it a little bit faster for you, but for part A, it says, what was the annual price of a gallon of gas in year 2000? If you started collecting your data in 2001, that's the first number on your table, that would mean we're going back in time to year 2000. So your x value would be -1. We're going back 1 year. So what I did was substituted -1 into my exponential equation. And I showed all the work over here on the right-hand side. Go ahead and take a minute, pause the video if you need to, and show all of your work. So the answer is, in 2000, I predicted the gallon of gas to cost around $1.22. You can pause the video and try the next few questions. I do have all of the work down on here, so you can kind of follow along. You can check your answers if you want to try them by yourselves. Part B says, predict when the price of a gallon of gas will be in year 2015. Well, if we started in year 2001, we'll have 14 years that have gone by. So I substituted 14 into my exponential equation. The answer is $4.47. Part C, we're going to go backwards. Part C says, predict when, so what year, would the gallon of gas cost $5? So we substitute $5 into my y. Well, unfortunately, you can't solve this by hand. However, you can use the intersection feature on your calculator. You would input your equation into your y1, and you would put, I'm going to go ahead and scroll down and show you. You would put your equation into your y1 on your graphing feature, and you would put $5 into your y2, and then find the intersection of the two lines. I'll just sketch a picture of what it would look like. So here's your function increasing, and $5 would probably be right around here. Okay, this is $5, and you are finding the intersection. You have done this in previous chapters. If you need help, please ask your teacher. It's the exact same for part D. So let's go back to part C. Part C, I found the intersection to be between 15 and 16. So that transfers to year 2016 to 2017. And for part D, same exact setup. $10 is substituted into your y value, and you need to solve for x. Using my intersection feature, I found x to be between 23 and 24, which transfers to year 2024 to year 2025. That's it for this video. Please watch problem 2 video.